Hey guys, so today we'll see when we will predict when bike parts like brakes or chains may break using data. So first we will see the practical part and then I'll show you the desired dashboard and how it should be present in the front end part. So in the first, as you see, the markdown cell, because that is not a code cell, but it's just a text title for our notebook, and the predictive bike maintenance is there, and hash just creates a Raj title. So the three steps that we are going to do in this is generate the data, train a model, and build an interactive dashboards. So in the cell 2, the setups and imports. So firstly, we'll import all the necessary libraries like pandas, numpy, and sklearn model dot selection and symbol import, and we are using random forest classifier. And like as you can see, sklearn dot ensemble import random forest classifier is there. So this is basically our AI's brain, and we are importing the blueprint for a random forest classifier. So this is a very common and powerful model, and you can see from sklearn.metrics import accuracy score. So this is our grading tool. So after we test our AI, we will use this function to compare its answers to the real answers and get a simple accuracy score. And as you can see, import IPY widgets as widgets. So this is our dashboard toolkit that we import IPY widgets and give it the nickname widgets. So this library gives us the code to create interactive sliders button and layout boxes. And you can see from ipython.display import display comma HTML. So display is like a super powered print command that can show things like our dashboard. And HTML is a function that would let us write and display the raw HTML and CSS code, which we'll use to make our pretty progress bars. And the print library is imported successfully. So this is just a simple check to let us know that our libraries are loaded without any errors. So now we'll see the phase 2. So this phase is to generate the synthetic data. So just like in our generate underscore data file, we just create a fake data set. So we embed rules into this data so our AI has the patterns to see. So now we are acting like data engineers. So we are creating the textbooks with a data like with a 5,000 rows or samples. So as you can see, the data, right? So the part type is equal to np dot random choice. So this will be our first column. So we use numpy's random dot choice tool to randomly pick either break or chain 5,000 times, right? So this is there. And the second one is a mileage since service. So this is something our next turn column, and we are generating 5,000 random integers between 0 to 2,000. So that would be age, months, like right, average load kg, Terence trace is there. So that all would be in this like mileage in service. So now we see, as you can see, Terence trace is also there. Then we are going to load the data frame. So this is a key step. We take our data dictionary and pass it to the pandas, that is PD, to create a data frame. And this is our Excel sheet in code for which we store in the variable TF, right? So after this, so we are doing the feature engineering, that is target variable creation. So this comment basically tells us here we are inventing the secret formula for the brake failure. So we are saying that the probability of failure is a combination of mileage, terrain, and average load kg, right? So these numbers are made up just to create a logical pattern. So chain failure problem is equal to mileage in service divided by 1800 plus. So we are doing the same for the chains, but we use age underscore months instead of average load kg. So we are deciding that the age is more important for a chain, right? So failure problem is described over here, and you can see chain failure problem is also there. So we are just doing the same for chains as well. And failure problem is equal to np dot where part type is equal to break, right? So this is a line like an if else statement. It uses numpy where to look at the part type column. If it is a break, then it uses the break failure problem, or else if it uses chain, it uses the chain failure problem. So you can see the failure problem is equal to np dot random normal, right? So this line just adds a bit of noise or randomness. So this makes our data look more realistic, like real world data, which is never perfect, right? And as you can see below that, df will fail soon is equal to failure problem is greater than 0.8, right? So this is our target variable, the answer column. So we are saying if the final probability is greater than 0.8, that means 80%, then set the new column to true. And the dot as type int then converts the true to 1 and false to 0. So this 1 or 0 is what our AI will be trained to predict, right? So 1 is for true and 0 for false. So then display df head is there. So finally we use display dot head to show the first rows of our new table. This is a crucial check to make sure that our data looks correct. So in this, like failure problem is greater than 0.8, that means greater than 80%, then it converts it to 1, that means true, and false to 0. So now we'll check the phase 2, that is train the AI brain. So now we will train using a random forest classifier to find the hidden patterns on our data. So the variable model will hold our fully trained AI brain. So we need to prepare the data that is there by using df prepared and pd.get dummies columns part type, and if first is column is true or not. So this is our main data preparation step. So our model does not understand like break or chain, right? So the get underscore dummies function is automatically that finds a part type column and converts it into numbers. So now it will create a new column that is part underscore type underscore chain. So which will be 1 because if it is a chain, and 0 if it is a break. So that will be there. So now the features, like we are creating a list of all the input columns. So these are the input columns that we want the AI to study. So as you can see, x is equal to df underscore prepared features. So we create our features variable x. So it's always uppercase by convention. So this x is a variable that is containing only our input columns. So y would be there. It is also a target variable, lowercase by convention. So it is a single line column which contains only the answer 1 or 0. So as you can see, this that then we are going to split the data, that is x train x test, y train y test is equal to train underscore test underscore split. So here we use our train test split tool. So we feed it our all x and y data. It shuffles everything and splits into four new variables. 80% for training, that is like x underscore trained, y underscore trend, and 24% for testing, that is x underscore test and y underscore test. So that is there. And this is a random state that we use. So now we will initialize, and the model we used is random forest classifier, and n estimator is equal to 100, random state 42. Then we are going to print, and model dot fit is also there. So this is the most important line in all machine learning. So this is the training. So we are training our model to fit itself to train, like study the training data. So it will look at the x underscore train inputs and y underscore train answers and learn all the complex patterns that connect them. So this is something that takes time, right? So now we'll see why predict is equal to model dot predict x test. So this is time for the exam. So we asked our trained model to predict the answers for the x underscore test data, which it has never seen before. So we store all its guesses in the variable y underscore predict. So now the print model accuracy is there. So this is our grading line, and we use our accuracy score to compare the model's guesses, that is y underscore pred, with the actual answers, that is y underscore test. So we multiply by 100 to show it as a percent. So this is how well our AI learned the patterns. So over here, as you can see, so for converting into the percent, we are doing this. So now we'll see the phase 3, that is the interactive dashboard. So over here, def create risk bar is there. So we are defining a helper function. It is a job to take the like break pads and a risk score like 0.85 and written a long string of HTML to display the pretty progress bars. And you can see risk underscore PCT is equal to risk into 100. So inside the function, we convert the risk to percentage. So that is why we are doing it. And you can see if risk is smaller than 0.4, else if 0.75 is there. So we are creating the bar function over here. So like this is a simple if block to decide what color will be there to used based on the rest code. And you can see written f. So this is the f string. It lets it put our variables like part name risk underscore PCT directly inside a string. So this entire string is HTML and CSS code to draw the nice looking result box and the progress bar. The slider box is also there. So this is the styling part. So we are defining mileage slider as well for this. So you can see mileage slider is there, age slider value is there, terrain slider is there, load slider is there. Then the input data, as you can see, that is for the brake. And input for chain is also given. So post that, we use the probabilities to like let the model predict it, and the brake risk and the chain risk as well. So we are doing that, and then we link the sliders to the prediction function, tell each slider to run update prediction whenever its value changes. So this is how pretty much the styling is done. So this is what the synthetic data that we have created with 5,000 symbols. So you can see if we do like this, So you can see if the mileage is going up, also going up. See, the prediction is it is making. So, okay, as you can see, if we are putting them kilometers above 1200, then we are getting high risk for chain also and brake pads as well. So this is how ideally the prediction when the bike like bike parts like brakes or the chain may break using data, right? So that's what the components would be like. We can also add more component, it depends upon you. So this will be the basic components that will be there, and you can see, okay, so you can see we have the EDA part as well. We'll see different one. So as we can check the mileage and service, the EDA is done. And you can see the age months frequency is there. This is for average underscore load kg. For part type is there. And this will be the 2D distributions. This it will be like this. This would be looking like this. This it would look like this. So the EDA part would look like this pretty much. So we would be needing to show all the graph distributions, categorical, whether it be so we or time series can be also done, and this would be all for the EDA part. Now we'll see the primary expectations for the dashboard and the front end part, that how exactly it should look like and the primary expectations for this. So this would be the primary expectation, or else you can enhance it as per your wants. So as you can see, if we are increasing, this feature is there, so it is predicting high risk. If we are lowering it, so it is working on that basis. So this is there. So I've stated like the project breakdown and the learning guide would be like, first the synthetic data creation is needed, and post that training a classification model, and then building a web API. So whether you can use Flask, right, and building an interactive front end. So the primary agenda lies over here. The dashboard should be interactive. So this is just an example that would be there to do it, or else you can enhance it according to you and as per your designing skills. But this would be the ideal expectations and the minimum requirements for the dashboard. So the dashboard should be interactive with the KPIs listed, and so this will be there for bike maintenance dashboard. And yes, not only this is required, you can add more features and enhance the bike maintenance model as well, like the maps as well. So that would be also, and the geolocation, so that would be also a prime feature that can enhance your systems. So this would be there. And like, as you already know, so first we need to create the data set. So as we did, then comes the feature engineering and target variable creations that we did as well. And then we need to add the randomness to make the data more realistic. That also we did in the Google Colab. So finally, the bike parts are saved, and post that we train the model with the training underscore model.py file. So this will be a separate file. So then we need to load the data from the CSV file that we have created. Then prepare the data for the model, because machine learning model needs numbers. So we convert the categorical part type, right, into numerical format using one hot encoding is there. So of course, targeting, defining the features and target y features. So features are the input and the target is the output that we want to predict. So x would be capital, just like we are following that, and y will be the small letter. Then we will split the data into training and test sets. So we train on the 80% of the data and get the test on 20% of the data, how well it learned. So as you can see, x train, x test, y train, y test. So the train test split is there. A random state 42 is used. Post that, yes, we need to initialize the random forest model, that is n estimator is equal to 100, means the model is made up of 100 individual decision trees. Then like evaluating the model's performance, then save the trained model. And the backend server would be pretty much like this for the Flask, if you're using Flask. So while using the Flask, we need to initialize the web application. So that basically enables the cross-origin resource sharing (CORS) to allow our HTML page to communicate with the server. So load the train model. So we do that and define the API endpoint for predictions. Get the JSON data sent from the front end. So the model was trained on the data for both parts. So we need to prepare for the input. So like for both break, that is part type chain is equal to zero and chain is part type underscore is equal to one. So the input data is also presented over here, right? So zero for input for break, one for the chain is there. And then we create a data frame with the correct column names the model expects. So as there, so the column names are my lesson, service, age, months, average, load kg, 10 stress, part-time chain is there. Then we need to get the predictions. Then we like prepare the response to send back to the front end. That is there for by creating the probabilities. And then we start the server by doing this, and that's how that comes to an end for Flask. And yes, so phase three is the interactive dashboard that I explained. So this would be the ideal dashboard because in the course which we used components, so I've listed like all of them. So it can be enhanced a bit more and like creativity can be added upon yourself, so you can do it by your own how you want to curate the dashboard. That will be there for the front end part, and we can also add more features to it and more components to it, so to enhance the bike maintenance dashboard that can be there. So as you know, so this will be the step by step guide to put it all together. So this is it for today. And I will be sharing the files to the support team and they will be sharing the files to you. So I hope you guys have started doing your project, right? Please start doing your projects and like this will be the ideal expectation for the dashboards and stuff. So I think this is pretty much about today. So I will be sharing the files to the support team and they will share it to you. So this is it for today. Then we'll wrap up the session. Okay, I'm wrapping up the session now. Thank you for joining.